All right, I got everybody's input. So last lesson, what did we do? We talked about the different kinds of chemical change, right? Okay, chemical reaction. So it has got to do with heat, light, electricity. Remember, we talked about all this, right? Yeah. So we also explore a little bit about the word equation. You tried writing word equation as well. Okay, so today's worksheet is on word equation, but also on the rearrangement of atoms. So this part you have not covered with me. All right, so just quickly, very quickly tell you what this is about. So for those of you who are doing this in school or already finished this in school, should be quite okay for you to follow. Now, so what happened to the atoms during chemical reaction? Okay, so you need to know the mass of reactants will be consistent with the mass of products. This also means that the number of atoms before and after reaction will be the same. Recall this one, right? Okay, can understand this part also. Okay, also we talk about, because atoms cannot be created nor destroyed. What goes in must come out. Okay, so if you put 5 in, definitely 5 will come out. Okay, so for example, this one, sodium metal reacts with chlorine gas to form sodium chloride. Okay, this is like the salt that you are looking at now. The mass of sodium metal and chlorine gas will be equal to the mass of their product. Okay, so whatever you put in, okay, is what you will get after the reaction. Okay, atoms are neither created nor destroyed, I mentioned earlier. So you need to know this. The mass of product is the same as the mass of reactants. Yeah, the mass of products, okay, will be the same as the mass of reactants. We also say the atoms of reactants rearrange to form new products. So it's only about the atoms rearranging. They don't disappear. They don't suddenly appear. They do not disappear as well. Okay, so whatever you have, they will just break apart first, okay, separate from where they used to be, okay, and then they will form new compounds. So it's a rearrangement of the atoms to get new molecules, something like that. For example, okay, sulfur react with oxygen to form sulfur dioxide. So sulfur looks like this, okay, and then you have oxygen. Oxygen exists as diatomic molecules. Okay, so when you talk about oxygen, it always has to take this particular shape, okay, where 2 oxygen atoms are joined together. This is our oxygen gas. So when sulfur burns in oxygen gas, we get sulfur dioxide. And then the bonds here is going to break, right? So after the bonds are broken, you have oxygen atoms. They rearrange themselves and they got attached to the sulfur atom in this manner. Yeah, so you don't have to worry about, okay, do I need to know what will break, what will form? How will they look like when they form? Not yet. At your level, you don't need to know all this. Correct now, Haresh? Are you falling asleep? No, good. So we have 1 sulfur atom in the beginning, 2 oxygen atom. What we end up with, sulfur dioxide, is still 1 sulfur atom and 2 oxygen atoms. No change. Nothing added, okay, nothing removed. They just rearrange themselves in this manner. So far, so good. So far, okay? Anyone not clear? All right. So like I explained earlier, oxygen molecule will be split up. They rearrange themselves, okay, so that each oxygen atom will combine with the sulfur atom to form 1 molecule of sulfur dioxide. Okay, So the number of sulfur and oxygen atoms stays the same after the chemical reaction. Now, another one, carbon and oxygen forming carbon dioxide. So carbon, so it's one carbon atom, and then oxygen, okay? Remember I said it exists as diatomic molecules. Then what happened is during this reaction, the bonds will break for oxygen atom here. Then each of them will combine with carbon to form carbon dioxide. Clear? Old bonds are broken, new bonds are formed. So this is how it happens. Then you can see that the number of carbon and oxygen atoms will always stay the same after the reaction. So far, so good. Any question that you have? No? Zenny, okay? Zenny, have you learned this part yet? You learned in school already. Good. Harini also? You learned as well, huh? What about Abina? Have you learned this?
Yes.
Any problem with this? No, right? Okay, always remember, okay, in any reaction, in this case is combustion, atoms are rearranged and never destroyed. Yeah, even though it's combustion, right? Okay, involving a lot of heat, a lot of burning, okay, you still never ever destroy the atoms. They only rearrange to form new products. Okay, and that's why we can say that the mass of products will be equal to the mass of reactants in one particular reaction. So far, okay? So that's all I have, for the rearrangement. Okay, we go into our worksheet first. All right, let's go into our worksheet first. And then after that, I'll be teaching you new things. Right, so this is the worksheet over here. So Gerald, what you do is, you can ask me questions should you be unclear about anything. Yeah, later on, I will share with you my email address. Okay, so any of you here, let's say you have certain questions. What you do is you take a screenshot of the questions that you have, or you can type into the email. Okay, send it to me. I can reply you. Because Gerald, you would have missed the last lesson, right? You said that you have already covered this in school, and then we already finished the first part of this topic. Okay, I can't be reteaching now. Okay, so what you can do is you can email me. Yeah? All right, that will help you, I guess. And I can send you whatever notes or videos that I usually share with the students. Okay, take a look. Can you see my screen? Can? Good. Okay, this is what MOE expects of you when you're doing this chapter. Okay, it's important that everybody knows this, right? Because at least you know what are the things that will be tested, what are the things you are still not clear of, okay, when you're revising. So for example, chemical changes, we're talking about this now, chapter 11, core ideas. Okay, these are the things you need to know. Identify a change that leads to formation of new substance. Okay, so we call it chemical change. Use word equation. Take note, chemical equations are not required. Okay, so this is what MOE stated for your syllabus. Right, and then they also say that, okay, chemical changes, right, or reaction involve rearrangement of atoms. They are not created, they are not destroyed. They are only rearranged. You also need to know that the mass stays the same before and after the reaction. Okay, and then show awareness that there are different types of chemical changes. Last week, we already covered combustion, thermal decomposition, oxidation, okay, neutralization. Then this part I have not started teaching yet. It is about acid plus alkali, acid plus metal, acid plus carbonate. I think a lot of students would struggle with this. Okay, you might be one of them, any of you here. Okay, that is, how would you know what kind of products will be formed? How would you be able to tell all right, what you're supposed to be writing. Okay, sorry, I just saw somebody in the waiting room. Then I'm wondering who is that person because all of you are here already today. Okay, right. So you will be wondering, okay, how do you get the products? Especially the name. Okay, for example, I put in hydrochloric acid with sodium carbonate. What do you think you're going to get as the product? Haresh, you know this, Haresh? If it's hydrochloric acid plus sodium carbonate, what will be the products? Or do you find that it's a little bit difficult for you to identify the products?
Is it like carbon dioxide, water, and oxygen? Wait.
Carbon dioxide is right, okay. And then do you struggle a little bit with this part? Because my other class, I have 2 classes of Sec 1, okay, two classes of Sec 2, 2 classes of P6, 2 classes of P5. So the other Sec 2 class, Haresh told me they struggle so badly with the acid reaction. Are you also in this category? Because if so, I'll be preparing extra work, extra practices, extra notes to help you along. Okay, how many of you feel that you want more notes for this particular section? Because this is also in Sec 3 and 4, and then the struggle goes on. Okay, all right. But if you are already very good, then I won't torture you with so many work lah. Otherwise, you will faint, if you get so much work from me, because I can keep giving and giving and giving, but it will make you become perfect, okay, in writing equations here. Okay, so we will talk about this later because later on, after the worksheet questions, I'll be starting on this part. Okay, now, then you need to investigate effect of acid, alkaline, neutral solution or indicators. So indicators will be litmus paper, universal indicator, all right, natural indicator obtained from plants. So what we can do is we can make our own indicator. We call it the red cabbage indicator. Not sure whether you heard of this.
See, like you blend the carrots.
Oh yeah, you did it?
No, my science teacher explained it to me.
Wonderful. Okay, we can try these. If you have some purple cabbage, red cabbage, you can use it. Even other fruits also can. So long as it's a dark color, like, grapes also can. Okay, you can also use this particular blue pea flower. It also changes color easily. Right, so we can explore that. I have the recipe for the purple cabbage or the red cabbage. Yeah, I usually make this even for my students, even for my nieces and nephews, just to play magic with them. Okay, investigate chemical changes, all right, that metal undergo. We already talked about this, right? Okay, heating, exposure to light, interaction with oxygen, using electricity. Yeah, mixing will be the one, okay, related to the top, which is neutralization. Okay, so far we have completed this part. Yeah, last week. Okay, we have completed this part as well. Okay, so we are only left with the acid reaction, which we will start on later. Okay, somebody. Okay, Sneha, you have internet connection issues. Yeah, you can actually log out and log in again, Sneha. Okay, don't worry, I'll let you in. Okay, let's start. Which statement about chemical reactions is correct? Okay. No energy evolved or absorbed. Not true. Okay, if you are going to talk about all of them, you can't make this kind of statement because, for example, electricity energy is involved, heat energy is involved also, light energy is involved as well. Okay, no new substances are produced. Okay, this is definitely false. All right, this is correct. Thank you, Haresh. Okay, mass is destroyed. We just said that mass cannot be destroyed because atoms cannot be destroyed nor created. Okay, thermal decomposition.